Hi guys, welcome to Scalars Mathematics class. Don't forget to subscribe to this channel, like and share this video. Alright, so today I want to talk about gradients of scalar. So when we talk about gradient of scalar, the first thing you have to understand about it is that when we write the gradient of this phi, it is denoted by the delta of phi over delta x of I. These are our I, j, and k are our vector quantities. Alright. So if we have delta phi over delta x plus delta phi over delta y of j plus delta phi over delta z of k, what we do here is that we take what is common between everything. And if you look at what is common between everything, you see that phi is what is common between everything. So that will be left with what? Delta over delta x of I, which is this, plus delta over delta y of j, which is this, plus delta over delta z, which is this. All right, then phi equals to, now this, all this in brackets, are what we represent with this sign, and this sign is called gradient. So this is what we call gradient. So that's why this topic is gradient of scalars. So all these things you are seeing here are what are scalars. All right, so we said here, where this sign is called del. If you don't want to call it del, you call it lambda. All right, if you don't call it del, you call it nabla operator. So it is either you call it del operator or you call it the nabla operator. And they said this sign, so this together is called gradient phi, because this sign normally is known as what? Phi. So if you don't want to call it gradient phi, you call it grad phi. Then they said grad phi is a what? Is a vector quantity. I'm sure we all know what vector quantity is all about. So now in this question we want to see the implication of this. So don't forget, this phi can be anything. So this phi can be v, it can be f, it can be any vector. So we just have to multiply it together for us to know the answer. So now we have a question here. They said if v equals what? X squared zi minus 2y cubed z cubed j plus x y squared z of k. Don't forget your I, j, k are vector what? Quantities. All right. So now I want to solve for the grad multiply by what? By v. So grad dot v, and I want to multiply what? Grad v. So this grad dot, this dot, we all know that this dot means dot product, while this means what? The scalar, and this means the dot product, while this means what? The cross product. So I'm going to do the two in this video so you can understand how we need to roll. All right, so don't forget to subscribe, like and share this video. To the first one now, we have grad dot v equals to, this is your grad here. They won't give you, you are expected to know it. All right, so you write this grad again here. All right, so we have I delta over delta x plus j delta over delta y plus k delta over delta z, multiply by your v, which you were given. Your v is what? X square zi minus 2y square, 2y cube z cube j plus x y square z k. All right, so first thing you must note is that when you are dealing with vector multiplication, you will have your ijk, but dot product is a scalar multiplication, and so everything you are going to have in your final answer will not be having the I again. And so that is why this I will be affecting only I, the j will be affecting only j, and the k will be affecting what? Only k. So rather than writing I, j, k again, I don't need them. Just write delta over what? Delta x, open bracket, the x, the first one which is for I, that's x square z, plus times minus will give you what? Minus. All right, so delta over delta y of what? The next one, 2y cube z cube j. No, I don't need to put my j again. Then plus, because plus times plus is plus, then delta over delta z of what? X y square z. All right. So now this one means you are differentiating with respect to what? X. This one means you are differentiating with respect to what? Y. And this one means you are differentiating with respect to what? Z. So let's differentiate with respect to x here. If you differentiate with respect to x, this will give us what? 2x. Your z is a what? A constant. All right. Minus differentiate with respect to x, 2y cubed, which will give you what? 6y squared. Your z is a what? A constant. So that's z cubed. Plus differentiate with respect to z. If you differentiate z, it will give you 1. So that will be what? Xy squared. All right. So that means our graph dot what? Dot v is what? 2xy minus 6y squared z cube plus xy cube. So let's see the second example. Let's see the second example now. Don't forget to subscribe, like, and share this video. All right. To the second one, which is what? Grad v. Now this one you have to calm down. So our grad again, which is what? I delta over delta x plus g delta over delta g, delta y, plus k delta over delta z. So everything here again, which is your v, that is what? X square z I minus 2y square, y cube z cube g plus xy square z of k. All right. So now, how will you do this? Listen well. Write your first value, I delta over delta x, multiplying everything there. X square z I minus what? 2y cube z cube g plus x y square z of k. All right. Plus j delta what? Delta z. All right. Delta y, everything here again. X square z I minus 2y square y cube z cube g plus x y square z k, plus the last one, k delta over delta what? Delta z of everything there again, which is what? S square z I minus 2y square y cube z cube j plus x y square z k. All right. So this is the first step. Now the next step is you are differentiating everything in this bracket with respect to what? X. You are differentiating everything in this bracket with respect to what? Y. And you are differentiating everything in this bracket with respect to what? Z. All right. So let's proceed. Don't forget to subscribe, like, and share this video. That will be what? Now differentiate with respect to x alone. I, j, k. When I multiply j is 0. When I multiply k is 0. Scalar quantity. When j multiply I 0. When j multiply j 1. When j multiply k 0. That means here all our value here will be what? I. All our value here will be what? G, and everything here will be what? K. Alright. So now let's differentiate with respect to z. Don't forget in differentiation, if you are differentiating with respect to x, anyone that don't have x become what? A constant, and a constant is what? 0. So now let me differentiate this first. If you differentiate this, that will give us what? 2xz. Why? Because I differentiate x squared, which is what? 2x, then z is a what? Is a constant. All right. Now if you differentiate 2y cube z cube, does it have x in here? No. Automatically 0. Plus if you differentiate this one now, x y square z, if you differentiate x, it will give you what? 1. So that I'll be having what? Y square z. Everything here is what? I. Plus the second one, differentiate to what? Respect to y, Is this having y? No,
No.
automatically 0. All right. If you differentiate this now, which is what? 2y cube. If you differentiate 2y cube, it will give you what? Minus 6y square z cube. If you differentiate this one with respect to y, it will give us what? 2, because this will become 2y. So you can write it as 2xyz. G, that's our G value. Then plus our K now, we have differentiated with respect to what? Z. If you differentiate this Z, if you differentiate it will give you what? 1. And 1 times Z square will give us what? X square. Alright? This with respect to what? Z. This will now be what? 2Z cube. If you differentiate 2Z cube, it will give you what? Minus 6Z square. So write your y for that y cube z square. Alright, then plus if you differentiate x y cube z, if you differentiate z, it will give you what? 1, and that will be what? X y square. Alright, so this is our I. So if you rearrange it, that will now be what? 2xy plus y square z. This is our for I vector. Plus times minus will give us what? Minus. So bring the minus out. Then this will become what? 6y square z cube minus 2xy z. The reason why this is becoming minus is because minus times minus will give what? Plus. Minus times plus will give what? Minus. So that is that. This for our what? Our g. Then plus our k value, which is what? S squared. So that's what? X squared minus 6y cube z square plus the last one, which is what? Xy square. So this for our what? Our z. All right, so this is everything. So if you are to calculate the cross product, which I'll be doing in my next video, that is all we have to do for today. So don't forget to subscribe, like this video, and share. All right, so before I go, you can try this assignment. So let's say you have your z, your v to be let's say you have sqyz I minus 4xy cube z square plus 3xy z cube. Cube here. Alright, so you can solve this, so you can know how to do this very well. So don't forget to subscribe, like, and share this video. Thank you.